important thing you want to consider is what you want to accomplish with that tool. So there are differences on if you are creating a reference rigid body or a reference tool compared to if you are tracking a handheld probe. If you're tracking a handheld probe, you want to make sure that you're going to be able to move that tool around in space and still maintain line of sight. You're also going to want to be able to track a point of interest, the tip of the probe, compared to the markers themselves. A reference, on the other hand, often doesn't move around in space, and so you have more design considerations on making sure the rigid body is large and has lots of markers on it, but you don't have to be as concerned about off-angle performance of it. So those are two things to consider, that what you want to accomplish with the tool.
I would say your first thing you should consider is what your target system you're trying to implement a tool for. If you have a passive-only system, then you would be looking at passive spheres or Radix or retroreflective discs, perhaps. If you have a hybrid system, then you can add to those a active wired tool and use active markers on it as well.
I would say when it comes to optical tracking, bigger is generally better. So a tool should be as big as possible, and it should also have as many markers as possible, because then the system has more sampling points. Now, unfortunately, that is in direct contradiction to ergonomics often. So the designer of tools has to kind of make a choice. How big can I make the tool? How many markers can I put on? And still make the tool not being obtrusive to the surgeon or whoever is going to use the tool. So there's some compromises to be taken into account there. And obviously on a C-arm tracker, where you can put a sleeve on the tracker, you can make a big tool with many markers easily. Something that is handheld, that the surgeon is using to, say, probe, often needs to be fairly compact, very ergonomical, and it cannot interfere with the surgeon's main objective to do his or her job.
There are several factors to consider. First of all, the camera should be able to recognize your tool, and for that to happen, the tool should satisfy certain constraints, such as the minimum distance between markers, and these constraints are typically provided by the camera manufacturer. If the tool is trackable, another factor would be the marker geometry and the location of the actual target that you want to track relative to these markers. These factors define how accurately you can track a given target.
Some other aspects of the tool design which you want to consider up front are: what type of markers do you want to use? Are the markers going to be single use and disposable? Are they sterile? Are they going to be reused multiple times and require sterilization? If that's the case, then you want to go with an active marker compared to a passive style marker. You want to consider whether the tool can be wired to a system control unit or not. Does it have to operate with battery pack, or is there benefit in not having any electrical components on the tool, in which case you would want to go with a passive style tool.